Welcome friends, welcome you all in my channel Chemistry the Mystery of Molecules. I am Tanmay. So today I shall discuss about superacids. Okay, so before going to details, I want to give you the today's point to be discussed. For example, the basic introduction of superacid, little bit about Hammett Acidity Function, and later I will give you a table you can consider about superacid. So this is our today's study plan. So before going to details, I want to give you a brief about superacid. What do we mean by superacid? From the name, you can have an idea. Super. This means extremely acidic. It's extremely acidic compared to traditionally used acid, and it is actually expressed in terms of acidity more than sulfuric acid 100% pure. Okay. And this actually, if I say this acid is stronger, this acid is stronger, then some value or some scale is needed to express them, that which one is stronger than which, and what extent. So that scale is denoted by this function, that is Hammett Acidity Function, and this is denoted by this equation. So what does it mean? What does it mean? Actually, in case of weak acid or aqueous solution, we consider as pH. Okay, pH indicates the concentration of H plus in solution. Okay, or more specifically, we can say H3O plus, or further accurate if we write, that is H plus solvated with n numbers of water. Actually, this species. Okay, so this is. So actually, strength is dependent by the extent of dissociation of an acid. For example, sulfuric acid to produce H plus or HSO4 minus, or you can say, you can further delocalize that H plus SO4 2 minus. So extent of proton donation capability or ionization is denoted by this pH. But actually here it is the aqua-based acid. This theory is true for aqua-based acid. But when there is no water, then actually in water this is the acid. When there is no water, how can we explain? For example, if we say if we say the pH is around minus 23. For example, I'll explain, some superacid has this value. Does it mean that it produces 10 to the power 23 numbers of proton? It is not possible. It is incredibly high. Incredibly. This much density of proton is not possible. So this theory is not enough to explain this superacid. So for that, this Hammett acidity function is needed. So in summary of this discussion, in case of low concentration based, this Hammett acidity function could be considered as pH. But in case of very high concentration, this should be then it should be replaced by this Hammett acidity function. And actually, from qualitative explanation, what does it mean for a superacid? Means its capability to protonate some. Acid means we say that capability to produce H plus, or more precisely we can say H3O plus hydronium. Okay, this is, and here superacid is capability to protonate or give proton to someone. Okay, this is superacid. So this is the basic of this superacid explanation. Means in case of superacid, what happens? This molecule, in case of superacid, this anion means, for example, if we consider HA, this A minus is extremely stabilized. That's why this proton prefers to remain in this stage. And if this is not stabilized, for example, previously it was stabilized by this H3O plus, but in case of superacid, no water is there, it is less stable. So this is less stable means it protonates someone more efficiently. That is the main basis of this super reactivity of this superacid. Okay. So this is, and traditionally the H0 value of concentrated sulfuric acid is minus 12. Okay, around 11.9. So anything stronger than concentrated sulfuric acid should be considered as superacid. Okay, so this is the main information we will keep it in our mind during this study. So after that we will now give a table, means few superacid names to explain. Okay, before that let me tell you some application of superacid. Application. From the name onwards you can see that okay, it should be useful in some case. Superacid means they are so much active that they can even protonate alkanes. For example, methane. What they produce? This from superacid. Always remember, only superacid can do this. Superacid, what it produces? It produces CH5 plus. Okay. This is called carbonium ion. Carbonium ion. In one of separate video I will explain this factor in details. And this is removes one proton to produce CH3 plus. This is carbenium ion. B-E-N-E-I-U-M. Carbenium ion. The difference, you can see the difference is carbonium, carbenium. It is CH3 plus, it is CH5 plus. This is the difference. How this happens? Actually, it protonates the CH bond. The CH bond is getting protonated by the superacid. Details I will explain in that video elaborately. So this is. Even it can protonate very unreactive alkane like neopentane, which contains a tertiary butyl carbon and 4, and it protonates this thing and produces this tertiary butyl cation, and this methane. Okay, and another application of this superacid is the stabilization of carbocation. This is a carbocation. In my previous carbocation video, I have explained that only the electron donating group, as this is electron deficient, so electron donating group means electron pumping to this center will stabilize. Okay, this is true because we are focusing at that time on this cationic moiety, but its stability also dependent on another factor, that is counter anion. Counter anion. So what superacid actually provides? It's a very common fact. The counter anion generated from a superacid is extremely stable. That's why that anion doesn't try to react with this. That anion is stabilized by itself. So if this cation is not that much stable, still it could survive. For example, methyl plus cation, even other cation also can stabilize because of the extreme stability of this anion. So this is, and it is a strategy. This strategy was followed to stabilize carbocation using superacid. Okay, and Professor George Olah is one of the pioneers in this field. So this is the in this way this superacid stabilizes the carbocation. Another thing, in industry, these superacids are used to alkylate the aromatics like benzene, it is relatively electron rich, even that relatively less electron like chlorobenzene, this thing, with ethylene, propylene, because in case of double bond, if we consider this double bond in presence of superacid produces similar carbocation, and that is stabilized similarly, like due to the extreme stability of this anion formed from the superacid molecule. So this is the main application of superacid. So now we will discuss about different superacid example. Today I will give mainly about examples of few superacid, and in some next video I have explained few of superacid which are, I believe, that relatively more important and you must know. Okay, so let's draw. For example, this is the compound and this is the H0. What do I mean? That Hammett acidity function. Okay, better write here H0. So let's first discuss about sulfuric acid. Its H0 value is around -12. From textbook chemistry, you know that perchloric acid is more stronger than sulfuric acid and it protonates sulfuric acid. But so next is perchloric acid, and its pKa is around its Hammett acidity constant H0 around -30. Why? Because this, if you consider this ClO4, it is a tetrahedral molecule. This is OH. This corresponding anion means O minus is extremely stabilized due to the resonance among these three oxygens. So equivalent canonical structure, they are extremely stable. So in this way, this this perchloric acid is stabilized. Okay. So next example is chlorosulfonic acid. What do I mean? Actually, sulfuric acid is this. So mainly they are the derivatives of sulfuric acid. Okay, this. So one is OH, means proton needed. Another is chlorosulfonic acid, and this H0 value is around -12.8. This is stronger than sulfuric acid because of the withdrawing effect of chloride, and withdrawing effect of chloride compared to oxygen. So this is second is fluorosulfonic acid. So if this chloride is replaced by this fluoride, which is more electronegative, then this is also a superacid, and its pKa value is around -15.1. Majority of data have been collected from Wikipedia, so you can check there. And similarly, this generally fluoro groups are highly toxic. That's why people prefers to replace this fluoro with CF3. So this is, so its acidity, this H0 value is -14.1. Okay, so this is the sulfuric acid derivative. So this is fine. Another thing I forget to mention, that is disulfuric acid, means H2S2O7. So this disulfuric acid is stronger than sulfuric acid, and its H0 value is -15. Now you may have question. Previously I have explained this is due to -I, this is due to -I, this is also due to -I, but why this? So for that you need to see the structure of this disulfuric This disulfuric acid looks like this. Okay, so now compare this sulfuric acid, this 2-hydroxyl attached to one SO2 group. Okay, here one hydroxyl is attached to one SO2 group. You can compare this fact like that, chloride attached. Like this is an electronegative atom and chloro CF3. So this withdrawing effect occurs. And consequently, this is more stronger because if it eliminates one anion, it produces this anion plus proton, and that anion is stabilized this way and this way with equivalent canonical structure. So that is the reason, that's why this fluorosulfonic acid, disulfuric acid is more stronger than this sulfuric acid. Okay, so now we will discuss about some other, these are the very simple molecule. Right now some other plant prepared superacid. For example, maglic acid. Maglic acid, and its Hammett acidity function is -23. It is one of the very strongest acid. Why? And actually its structure, actually it is prepared by fluorosulfonic acid plus SbF5, so antimony pentafluoride. And we are now discussing their 1:1 mixture. In a separate video I will details discuss about this. So how it is that much acidic? Because of the Sb is preferred to have 6. So previously it has 5 fluoride ion, and after protonation, actually this proton is coming from this SO3H, means this S double bond O, this OH. So this OH produces proton and consequently O minus is produces, and that O minus is coordinated, and in this way this is stabilized. Okay, sulfur is tetrahedral, and this O minus means this O negative charge is completely delocalized. That is the reason for its extremely high acidity. Even this ratio could be changed if actually if 2 amount of F6 is taken, then another acid could be generated which will have a different type of stabilization. Means even it could be more acidic, further more acidic. And another important thing is that fluoroantimonic acid. Fluoroantimonic acid. Its Hammett acidity function is slightly greater than this, that is more than -3. Okay, so what is this? And it could also be a different ratio. Actually, its counterpart is SbF5, and this part is, so you can consider that is a derivatization. For example, sulfuric acid with SbF5. Now with some another acid, and that acid is HF but twice. Okay, so what it produces? This HF has a unique property. Unique property, what do I mean? This HF, into 2 molecules of HF ionizes to produce HF2 minus plus HF2 minus plus H plus. And actually more accurately, if we say this is not H plus, this is HFH plus. So HFH plus. So here you should have, this is 3. Why? It is important. Please focus, give your attention. Why? Because this fluorine makes very strong hydrogen bonding. That is why this F minus, remains hydrogen bonded, means these bonds are hydrogen bond, but these are so much stable that it is very difficult to distinguish which one is actually fluoride anion, means which one is actually HF bond and which one is the hydrogen bond. So this bond is very strong. It is a unique exceptional example. So that's in this way, due to the hydrogen bonding, this F minus stabilized, and this is another exception, because when we write proton aqua based acid, we generally write H3O plus. Okay, what does this H3O plus means? H3O plus means this oxygen, this, and it is attached to one lone pair. Okay, if in case of that we take HF, then it must be this, and it has 3 lone pair, and similarly it attached to proton. So that is similar type of this. So you can understand, in mineral we usually explain about aqua based acid. This is HF as a medium, means aqua, water as a medium for acidity, here HF as a medium. Or so this is the reason for its stability in this way. So what happens if we take this, then what is produced? In this case, what is produced, that is HF HFH plus SbF6 minus, just SbF6 minus. Okay, you know that this antimony is stabilized due to the 6 fluorine, that's why it is F minus. But the question is, I have explained this, the stability of this also, but the question is why it remains in this way. It should have been remained as a H plus and SbF6 H plus and SbF6 minus. Why not this? Actually, it depends on the stability, because bare proton is extremely unstable, and that's why it will try to take one fluoride from here to make the complex ultimately unstable. That is why this proton is stabilized by hydrogen bonding with this fluoride, and that's why this charge is stabilized. Means this, if we consider this proton is from H plus, so this is hydrogen bonding, but hydrogen bonding is so strong that it is very difficult to predict that which one is actually the proton. So this is the thing. Another thing, that even this SbF6 ratio could be plus SB2F11 overall minus. So this is also possible. So changing this, the acidic strength also changes. So another type of acidic material is carborane based superacid. Carborane based superacid, which has this Hammett acidity function around -8. It's very strong, and it is very strong, and its structure, actually it is little complicated structure. In short, I can write it CHB11Cl11. This is the thing, and this proton is donated to show its superacid character. So this is, so till now we have observed this. Apart from this carborane based acid, others are means inorganic based acid. Now question appears for a simple fantasy that whether any organic superacid possible. The question is yes, and it is based on the proper design. What is the superacid? Triflidic acid. Triflidic acid. And actually I couldn't get the Hammett acidity function of this acid through my study. So I request you people that if you get its H0 value, please mention it in the comment. What I obtained, this is 10 to the power 4 times stronger than triflic acid. acid. Triflidic acid means trifluoromethyl sulfonic acid, CF3. So it is a superacid. I have explained just sometimes before, and this has a H0 value around minus 14.1. So it is stronger than this, and definitely this is a superacid, and actually it's a carbon-based superacid. And what is the structure of this triflidic acid? This is CH attached with 3 SOCF3, triflet. Similarly SO2 CF3, similarly SO2 CF3. Actually, generally we say CH bond is not that much polar, that much acidic, but this is an exceptional example based on proper design. Design means that if this proton is abstracted, the corresponding anion is extremely stabilized by this in this way 6. Second point, the withdrawing effect of CF3 also. So this is the reason how this is stabilized, and a carbon-based superacid means CH bond acting as a superacid is possible. So this is the end of my today's discussion. So in next discussion I will explain few very important superacid. So if you like my videos, please give a like, means thumbs up, and share this video among your friends that other people also get benefited from my effort. And finally, subscribe my channel Chemistry the Mystery of Molecule and press the bell icon to get the every single notification of my new video. So thank you everyone. Let's see you in my next video.